Okay, today's lesson is about square roots and real numbers. So there's a few things that we need to cover today. First of all, this symbol is called, some of us just refer to it as the square root sign, but its real name is called a radical sign. So if you hear me refer to something as the square root of a number or radical the number, that's what I'm talking about. And what the radical sign means is it is indicating the non-negative or principal square root of the number under the radical sign. Okay, so an example of that would simply be, we'll start easy. If I have the square root of 64, that would be 8, okay? Because 8 times 8 is 64. So I'm looking for the number that times itself will give me the number that is underneath the radical sign. I can also, if I would like the negative square root, I can just put a negative sign out in front of it. So if I put negative radical 64, that would mean that I'm looking for negative 8. Sometimes you might also see the symbol plus or minus. So if I wanted to see the positive or negative square root of 64, I would write it that way. And then my answer would be plus or minus 8, positive or negative 8. Okay, so those are the basics. Now we can take that and we can also do fractions with square roots as well. So if we have a fraction, let's say we have 64 over 49 underneath a radical sign, we simply take the square root of the top and the square root of the bottom, and then we're done. So the square root of 64 is 8, the square root of 49 is 7, and we're finished. Okay, so just because you see a fraction underneath the square root sign, don't go running for the calculator. Look to see if the top and the bottom are what we call perfect squares. If they have a square root that is an integer. Okay, so we will say here, let's add that definition to it, that a number is a perfect square if it has an integer for its square root. Okay, so 64 and 49 are both perfect squares. Other examples of perfect squares would be 100 or 25, okay, because they have an integer for their square root. Okay, so that's what the first side will be like. They're going to throw in some decimals in there too on you, but don't be worried or concerned about the decimals. If, for instance, they throw in the square root of 1.21, okay, well, think about it. Look at it first if there were no decimal place in it. If we were to ask you what the square root of 121 was, the answer would be 11. So if we're asking you for the square root of 1.21, well, it's just going to be 1.1. Okay? So think of it, take out the decimal at first and think of what the square root of the number would be without the decimal, and then add the decimal back in when, before you complete the problem. The next thing that we're going to talk about on the worksheet has to do with something that keeps popping back up all the time. We did it last year, we did it this year already. Here it is again. So we are going to take some fractions and decimals, and we're going to say what set of numbers does that number belong to. So, for instance, if we have 49 over, let's say, 24. Okay? We want to look at that and say, okay, what set of numbers does that belong to? And we're talking about natural, whole, integer, rational, irrational, etc. Well, first of all, we know it's not natural, we know it's not whole, and we know it's not an integer, because those three categories can't be fractions, okay? So in order to know whether or not this is rational or irrational, we need to put that into a calculator. As it turns out, when we put it into a calculator, we get 2.0416, and then the 6 begins repeating. So repeating decimals, we know, are rational. So once again, that has come back, and you need to know how to do that for the back side of the worksheet. Also, they have some problems where you're going to write a set of numbers in order from least to greatest, which sounds easy enough, except some of them will be fractions, some of them will be decimals, some of them will be square roots. So what you're going to have to do on that part is convert everything to one or the other, or just kind of use some logic. So let's take a look at an example. If I were asked to order the negative square root of 1.44 and negative 0.35 and 1/5, okay, I could do this fairly easily because, I have some kind of number sense. First of all, we're going to look at it and go, okay, well, negative numbers are going to come before positive numbers. So I know that either this number or this number will be first. So I'm just choosing between these two because they're the negative ones and they're going to come before a positive number. So I'll go ahead and figure out what the negative square root of a 1.44 is. Well, I know that the square root of 144 is 12. So if I know that, then I can write 12. I know it's negative, and then I'll put my decimal place back in. So this is a negative 1.2. Okay, so I know negative 1.2 comes before negative 0.35. So negative 0.35 will be next, and then my positive number will be next. So it turns out I didn't have to reorder these. They were already in order from least to greatest. But it won't always work out that way. So you have to either, convert them or use some common sense about, well, I know negative numbers come before positive numbers. And, you might need to convert some decimals into fractions or fractions into decimals in order to be able to figure out what comes first. Let's just do one more example of that. Okay, if we look at this example, I have negative 2.37, the square root of 5, and negative 7/2. So first of all, look at it and go, okay, my negative numbers have to come first, so it's either this one or this one. It would probably be easiest if I converted this fraction into a decimal before I tried to compare these two. So I'll rewrite negative 7/2 as negative 3 1/2, which is the same thing as negative 3.5. Okay, well, negative 3.5 is less than negative 2.37. And then, of course, the square root of 5 must come next. And I don't even need to know what that number is. I know it's next because it's the only positive number. So that's it for today, and hopefully this was helpful.